we have one lady from China Engineering Institute, Earthquake Institute, Gu Yuan Gao. I hope that I pronounced well. So the floor is yours.
Thank you very much. My name is Gu Yun Gao. I come from China Institute of Dynamic Crustal Dynamics, China Earthquake Administration. The title of my presentation today is the fracture behavior of rock plate under static and dynamic combined loads. Oh, okay. This is the outline divided into 5 parts. First, introduction. As we all know, dynamic fracture of rock materials plays a vital important role in geophysics process and geoengineering applications, such as the earthquake, landslide, underground rock blasting. There's the accurate measurement of rock fracture parameters, such as the fracture energy, the crack propagation velocities, the fracture toughness, and the stress strain field evolutions is of vital importance. As we all know, for the static or quasi-static fracture parameters, there have lots of methods, and they also have the ASRM suggested method for measuring the fracture toughness. But for dynamic fracture toughness, there are little methods. Here, I listed just one, and Joe and Echo suggested use not semicircular bending specimen to test the dynamic fracture toughness. But for combined loads, there's no fruitful method. And there are 2 challenges for combined load fracture. First, there is the confining stress influence the dynamic parameters, such as the dynamic tensile strength or the fracture toughness of rock materials. And so maybe the testing method may be also quite different from the single load. The second is dynamic fracture behaviors under combined load, maybe so very peculiar behaviors, such as in 2005 found that the supercell rupture happens under the compression and the dynamic combined load. For the dynamic fracture testing method, here I categorize into 2 kinds of methods: electronic measuring method and optical measuring method. For the electronic measuring method, such as the method use the load displacement information or the strain near the crack tip to calculate the fracture toughness or the fracture initiate time. This kind of method just measure 1 or 2 parameters of the fracture of rocks. But for the optical method, such as the photoelectricity, caustic method, or the digital image correlation method, this kind of method can measure the full field deformation or the stress field near the crack tip, so one can obtain more information about the fracture behavior of this material. Here, we use the digital image correlation method to study the dynamic fracture of rock under combined load. Measurement method. The digital image correlation method deal with a series of images, one before deformation, we call it reference. The other is deformed images. This is a series of deformed images during the dynamic fracture process. We track the a subset in the deformed image. So we can find the location of the point P here, or the P plus. Then we can determine the local displacement. For the full field mass measurement, we track the full. We divided its deformed image into several sub-images. So we calculated the correlation coefficient and find the optical value of the coefficients. Then determine the correlated point from the reference, the deformed image of the and the reference images. So we can determine the U and V displacement fields. Next, combined with the fractal mechanics analysis, we use the displacement field near a crack tip, and by using these schedules, we can determine the crack tip position and the stress intensity factor during the fracturing process using a least square method here. So we can get the crack tip position, the crack propagation velocity, fractopony, and other fractal parameters. Experiment. We use this rock plate. It's about 350 plus 350. The parameters is here. The loading. No. The dynamic loading was exerted by this split Hopkinson force, which include a gas pressure gun, a striker bar, an incident bar. Here, we machined this incident bar to the wet shape, and here use an adapter to exert the extension or open force near this end of the spaceman. And the static compression load was exerted by a hydraulic pump with an adapter here. The dynamic process, fracture process was recorded by the ultra-high-speed camera with a frame rate of 50,000 frames per second. Here is a typical result of the displacement fields and the shear strain field evolution images. Also, we can see that the displacement field and the shear strain field first increase with the dynamic process, and about 120 microseconds, the displacement reaches maximum value, and the crack initiates. Here is the final crack path compared with the opening displacement and the strain field. Next is the loading rate effect. Crack propagation velocity and the fractophonies all increase with the impact force. Impact force here. The crack propagation velocity here is about 1.42 Rayleigh wave speed to 1.57 Rayleigh wave speed. It's higher than the small specimen. The fractotoughness increased about 30%, 60%. Here is the fractal metallography of all the specimen here. With the loading speed increase, the crack bifurcation occurs here. Next is the confinement effect. The displacement field here has a little different with that figures before. You can find here with the loading in the loading space loading process. This opening displays the first increase, but when it reaches maximum values, it did not increase anymore, and crack arrest happens. Here, for hydraulic pressure, we used. The result is here. And the crack propagation velocity and different hydraulic pressure are quite different. It decreased about 47%. And the crack path also quite different. Here is the crack is repulsive, but here the micro crack were formed near the crack path and the crack tip. The final crack length also decreased with the increase of the hydraulic pressure. Conclusions. By using the digital image correlation method combined with the ultra-high-speed camera, we get the fractal behavior of the rock plate under static and dynamic combined loads. The crack propagation velocity and fractotoughness increase with loading speed. The crack propagation velocity and the crack arrest length decrease with increase of the hydraulic compression pressure. Micro cracks could be observed near the crack path and the crack tip when the rock plate is subjected to the hydraulic compression and dynamic loading. This work provides a new method for the investigation of dynamic failure under static confining pressure in deep underground engineering and earthquake fault rupture. Next, we maybe do some work based on this work using a triaxial compression machine to exert biaxial compression pressure and dynamic loads. Thank you, that's all.